Hi parents. So there's been a couple of requests and some confusion about how the kids are multiplying with our strategy called area model. So I'm going to preface this by saying you are probably going to not like it, but once the kids kind of get the hang of it, it does help them by kind of breaking apart their multiplication facts into smaller, what we call friendlier numbers. So for example, if you remember trying to memorize 7 times 8, that's kind of a difficult fact, but it's not too bad when you know your 5s, your 2s, your 1s, and then when you get into double digits, your 10s. And so that's kind of what it's all about. So I'm going to do a sample problem for you today. I'm going to start by solving a 1 digit by a 1 digit, and then I'll show you a 2 digit by 2 digit. So students have access to this. This is called our grid paper. This paper actually comes in their STAR test booklet, and so they will have this for the STAR test, and so we're kind of trying to get them practicing now using this. Some of them are using this. Some students are using blank paper, and I'll show you how this works on blank paper at the end. So let's say we have the problem, let's go 7 times 8. So 8 is not very friendly, and neither is 7, but we are going to do what's called decomposing. And so students need to kind of stop and think about what number is going to be easier to break apart. So I know a 7 is going to be composed of a 5 and a 2. And 5s and 2s are very easy to count by. So I'm going to place the 7 at the top, and so they need to count across 7 squares. So 1, 2, 3, 4, 5, 6, 7. And then we're going to have 8 in each. They're going to count down 8. 1, 2, 3, 4, 5, 6, 7, 8. And then they make their area model. And so you can see it's basically length times width. But we don't introduce that to them until 4th grade. So I mentioned decomposing. So what they would want to do is they're going to take the 7 and they say, okay, I know 5 and 2. 5 plus 2 makes 7, and both of these are friendly. Sometimes that works out, sometimes it doesn't. There are some kids who like to do doubles, so they might choose to keep the 7, put the 8, and split it into 4 and 4. So there's not really a right way or a wrong way to decompose, but I do really emphasize that they use those friendly numbers as much as possible. And so then what we're going to do is look at this section and come up with our equation for this section of the area model. So we have 8 rows, which would be 8, and now there's 5 in this section, so 8 times 5. Then you're going to focus on this section. This is 8 rows with 2 in each. And so then they solve each little piece. So we know 8 times 5 is 40. And we know 8 times 2 is 16. So we call these partial products because they found the product, the answer, but it's only a part. So we broke the number apart. We have our partial products. We need to put them back together. And so kind of some of them are able to do it in their head. Some students need to rewrite this down. As long as they get the correct answer, it's fine. So now they know 8 times 7 or 7 times 8 equals 56. Is this easier if they just memorize their facts? Absolutely. But in my 10 years of teaching, very few kids actually memorize their facts. So in the ideal world, yes, we would not do any of this for 8 times 7. They would know 8 times 7 is 56. But until they get to that part in their brain, until they understand that, this is like a strategy. They can break it up, they can chunk it, and they can get there. Do we want them doing a basic fact like this in 4th grade? No, they do need them to know these facts in 4th grade, and that's why we're really practicing our facts right now. So here is how 8 times 7 would look without grid paper. Some students prefer this method because they don't actually have to count squares. They just kind of estimate. So the same process, decompose your 7, multiply, and then add your partial products together. So some students like the grid because they do use it to help them count. But some students don't like counting, or they're just not very neat and organized, and so just having a blank space to work on is best for them. If you're still interested, you're still with me, here's how you would do a 2-digit by a 1. So I think in the math review, what I sent, it has ends up being 7 times 16. So I've told the students, whenever you have a 2-digit number, that is going to be what I want them to decompose. And we only pick one number that we're splitting up or decomposing. And so then their 7 is going to be here on the side. So 7 is not very friendly, and so it's very important that they see the different parts of 16 that they can break it up into. Let me see. So 1, 2, 5, 6, 7. I did one too many. And then you're going to come across 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you can kind of see where these squares are a little more time consuming. And if they count off one, then it does throw them off. And so I would like for them to move away from the squares onto blank paper, but some of them just are not ready for that yet. So I know I can pull out a 10. So 10 is very friendly. Kids can skip count by 10 very quickly. 6, not so much. But if you think about the numbers in 6, well, I know 5 plus 1 makes 6. And 5 is friendly, and 1 is friendly. So I'm going to decompose my 10 into 5 and 1. So they do need to label so that their numbers are going to match that section of the grid. So 1, 2, 3, 4, 5. And then here's their 10. So you're going to have 3 pieces in this area model. So you've got 7 rows, and this section has 10 in each row. So for this portion, 7 times 10 represents what is here. Then we're going to do this piece. You still have 7 in your rows, 7 rows, and there are 5 in each row. And then this one, I'm going to turn it. You still have 7, and there is 1. I really don't want students to break it up into maybe more than 3, 4 at the most, because once they do start breaking it up too tiny, they're more likely to make errors. So if they're breaking it up into 4 pieces, then there's probably a friendlier number they could have used, like 5. So 7 times 10 is 70. So kids can skip count by 10, friendly. 7 times 5, again, your 5s are friendly. Most students can skip count by that, by 5s. And then our 1s, we've talked about the 1s. Most students are pretty quick with the 1s. So now you've taken 7 times 16, and you've broken it up into smaller chunks that you need to put back together. So in 3rd grade, we don't add more than 2 numbers together at a time. So they would need to add whichever 2 they want. So you can kind of see where too many pieces gets a little bit complicated, but that's that. I feel like I did something strange. Hang on, let me take a look at this. Nope, it's all good. So me, speaking as a former child who never quite memorized my multiplication facts, this is helpful. Every now and then, though, I do things where I'm not quite sure. So again, same concept, but really quick without having to count squares. Just a little bit more abstract, and so some kids, again, just aren't ready for it. Exact same idea, but you're not counting anything out. So you still have 7 times 10, 7 times 5, 7 times 1, 70, plus 35, whoop, sorry, plus 7. So then 70 plus 35 is 105. I need to add 7. I guess technically regroup. So 112. So then they know 7 times 16 equals 112. So 2 different approaches, but the same concept both times. I hope you find this helpful. I hope you don't hate it too much. If you have any other questions, feel free to shoot me an email and just let me know. Thanks. Bye.